Okay, question number 3, assignment 1. An object moved along the x-axis with an initial position, blah, 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 blah. The velocity is given by v of t equals sine of pi thirds t. Part A, straightforward enough. What is the acceleration of the object? So what is the acceleration of the object, and what does that mean? That means v prime of t. So I'm going to have you pause the video, and you can solve this out and see if you get the right answer. Okay, so here's your derivative, real straightforward. The acceleration is v. Now we need to evaluate at 4. So we're looking for a of 4, which means we're evaluating this function at 4. All right, so I'm going to let you again do this, but this is going to be an important way to think through this. So I'm going to walk you through it in a second after we get back to it. Okay, so this we need to think of to do this as a reference angle. So when we talk about this, we're really looking at the pi thirds to begin with, which we know to be 60 degrees. We know that cosine of 60 degrees is 1/2. And now we got to look at 4 times 60 degrees. So really this is 240 degrees, or the third quadrant where we know cosine to be negative. Again, the pi thirds are 60. 4 times 60 is 240, which means third quadrant, which means we know it's 1/2 due to reference angles, and we know it's going to be negative. Therefore, this becomes pi thirds times negative 1/2, which equals negative pi 6. Check. Okay, statement 1 for part B, the velocity is decreasing. The velocity v prime is equal to a of t, so our acceleration. And from 3 to 4.5, it is negative. Therefore, yes, the velocity is decreasing. Okay. Statement 2 for 3 to 4.5, the speed is increasing. Remember, with speed increasing, we're talking about two things. Either the particle is moving away from the x-axis, whether it be in the negative moving away from the x-axis or the positive moving away from the x-axis, or both the velocity and the acceleration are the same sign. In this case, both velocity and acceleration are less than 0. So yes, the speed is increasing. Okay, part C. What is the total distance traveled of an object over the time interval of 0 to 4? When we're talking about total distance, we're talking about we need to identify where it turns around, where the particle turns around, and then we're going to add up all those distances. Or more simply, we simply integrate the absolute value of the velocity function. So remember, our rate of change, our integral of our rate of change is total distance traveled, right? But if we're talking about changing direction, is displacement. But if we're talking about changing direction, we need to disregard the displacement and talk about just total distance traveled. And that's the absolute value, the integral of the absolute value. And this will give you your answer. Okay, and part D, what is the position of the object at t equals 4? So at this point, we're talking about our initial position, which is our x of 0, plus our displacement from that point. Now notice, this is the absolute value, this is the distance traveled, this does not take into account the absolute value, therefore this can go right and left, therefore this is our displacement. So this is our distance traveled with the absolute value. In this point, our position needs to take into account our change in direction. So in this case, our initial position plus the integral from 0 to 4 without the absolute value. Okay, here's question number 4. Again, assignment number 1. Just so we're clear again, pause this at this stage so you can then read the question. I don't have to reread it to you and take your time. So pause this and reread it. Okay, part A talks about relative extrema. So we're looking at where the derivative is possibly changing direction. So we look at this function and we realize that we're looking at the first derivative, remember, so we're looking at this, and it goes from positive to positive, so that can't be a relative extreme. And it goes from positive to negative right here, and then negative to negative. So the only location where it could possibly be a minimum or a maximum is this right here. And in fact, even though it does not exist, that is absolutely in this case, a relative maximum, because it goes up, stops, and goes down. So the only relative maximum here is at x equals 2. Okay? There's no relative minimum. Okay. We're going to sketch the graph here. I gave you a little bit bigger. This tiny little axis is not enough. So to sketch the graph here, we're always going to start with our x, y coordinate points. So we're looking at these points right here, 0, negative 1, 1, 0, so on and so forth. So I'm going to plot these points. Let's make them in pink, hot pink. Okay, so this is 0, negative 1. This is 1, 0. This is 2, 2. And 3, 0. And 4 is our unknown. Okay, so that's the first thing we do. All right, the second thing we need to do is determine, first of all, it's increasing. So we know this is going to be, this is my positive slope from 0. Remember, we're talking x value, 0 to 1. So this is going to be going up. The thing we need to concern ourselves with is the concavity. So we know it's going up, but it has a negative concavity. So it's going to be doing that. Okay? All right. And then we do the same thing the next segment. It's going up again, positive, but has a positive concavity. So all the way to there, it does that. All right. Then it goes negative. In other words, going down. That's this part here, and it has a negative concavity. So we're here. Now remember, this value does not exist. This derivative does not exist. So I don't need to make this a smooth curve. I can just do that. So that has a negative slope, check, and a negative concavity, check. And lastly, continued negative slope and a positive concavity. That means concave up. That means that. So there is our graph. Okay, again, we start with the xy coordinate points. And then we really just pay attention to the concavity because the slope is sort of predetermined if I'm connecting the dots. All right. Okay, part C, let g be the function, this integral right here, right? On the open interval 0 to 4, for all these values of which, find where g has a relative extreme, a min or a max. Determine whether g is a relative max or relative min in each of these values, and justify your answer. Well, the first thing we need to know is if if we're looking for the function g is a relative min or max, then we are looking where g prime is equal to 0. That's step one. See if you can start. So what this is saying is really, when is f of x equal to 0? That's my question, right? Because we know that. We don't know when f of x is equal to 0. And that is at x equals 1 and x equals 3. We then need to look at those values and we need to say, all right, which those values does this go from positive to negative or negative to positive? For x equals 1, it goes, when we're talking about our f values, we're talking goes from negative to positive. So in this case, this goes from negative to positive, which means we're going down and we're going up. This is a relative minimum. Okay. Our verbiage here would be this is a relative minimum because it changes from negative to positive. And lastly, bx at 3 goes from positive to negative. Therefore, that is going up and going down. That is a relative maximum. Again, justification being the function f or g prime goes from positive to negative at the point x equals 3. Okay, part D is a point of inflection. And again, with these types of problems, the good thing is once we have an idea as to what we're doing, in this case, the fundamental theorem of calculus, the rest of it really falls into place. So in this case, point of inflection is where the g double prime is equal to 0 or where f prime is equal to 0 or undefined. F prime is 0 or undefined at x equals 1 and x equals 2. And at x equals 1, it goes from positive to positive, therefore none. There's no point of inflection. And at x equals 2, it goes from positive to negative, therefore a point of inflection. All right, and that's that. Okay, here's question number 5. Gives you a table of values of f of x, f prime of x, g of x, and g prime of x from 1 to 4. It talks about being differentiable for all real numbers and strictly increasing. Therefore, the table gives us the functions of the first and second derivatives. And it says the function h is given by f of g of x minus 6. At this point, I'm going to let you pause it and see if you can make sense. Forget the questions. Just make sense of the information given to you. Okay, so this information given to you is, we should feel okay about this. Now, when we see this right here, we need to be thinking chain rule. They're going to be asking us about the derivative, and we need to be thinking chain rule, so we need to be aware of that. All right, part A, explain why there must be a value r from 1 to 3 such that h of r equals negative 5. Okay, so the reason this is because it's going to be a intermediate value theorem problem, and we're going to work this out ourselves. So here is this whole thing. I'll let you read that real quick. Okay, and then you read, you're evaluating g at 1, f of that result is 2, getting 3. Then we do the same thing for the next value, and we find out that our value of h of 1 is 3, and our value of h of 3 is negative 7. Therefore, they must pass over negative 5, only because we know it's continuous. If we don't know it's continuous, we cannot use the intermediate value theorem. Once we know it's a continuous line, therefore the intermediate value theorem means there must be some h of r where it equals negative 5. So I'm traveling from 1 to 3, and I'm going from my y value of 3 to my y value of negative 7. It has to cross over the horizontal line, y equals negative 5. Okay, part B. Okay, so very similar question for the next piece. Why there must be a value c from 1 to 3, or it's between 1 and 3, such that h prime of c equals negative 5. Well, this is the mean value theorem, which means we're taking the average rate of change from 3 to 1, or 1 to 3 doesn't matter, and we're solving it, and we get negative 5. Therefore, there must be some value from the mean value theorem where h prime of c equals negative 5. Now, this means the only way we can apply this is if this is continuous and differentiable. It needs to be differentiable. It can't, well, I'm not going to put that there. It can't be a situation where it's not differentiable, because then we can have a sharp curve. So in this case, it's continuous and differentiable. We mentioned that in the very beginning of the whole thing. It's differentiable. Therefore, the mean value theorem applies. Okay, part C, we have the integral of w to x from 1 to g of x of f of t dt. We take the derivative, which means we need to use the fundamental theorem of calculus using the chain rule. So instead of just f of x, it becomes f of g of x and g prime of x. Evaluating all of those values, gives us negative 2. I know I'm going fast, but I want to give you time to finish this video. Pause. Okay, last one, the inverse function. G of inverse is equal to the inverse of g of x. Therefore, g of g inverse is equal to x. We take the derivative of this, which means we need to use the chain rule. G prime of normal inside times the derivative of the inside equals the derivative of x, which is 1. And we solve this whole thing for g inverse of g inverse prime. So divide by this whole thing, and this is our derivative. Okay, so we just divide it by this. And then we evaluate at 2, and we end up with 1 over g prime of g inverse of 2, which is equal to 1 over g prime of 1, which is equal to 1/5. That is our slope of g inverse at 2. The xy coordinate is 2, 1, because g of 1 equals 2, therefore we do the inverse. Therefore, our final question is y minus 1 equals the slope, 1/5, x minus 2. I'm sorry I went fast there, but I wanted to finish for only 15 minutes.